All right, this is the practice chapter 3 test, and as always, I am the amazing Mr. Jansen. So away we go. If we take a look at these first two, they're asking us to solve by graphing. And this first one's kind of set up nicely for this. These are both in slope-intercept form. So I've got my y-intercept here as the -4, so I'm going to go down to -4 and put a point. And then the slope is 2, so that's up 2 over 1, up 2 over 1, 2 over 1, so on and so forth. And then I draw a nice line. Oh, that looks beautiful. And if I look at the next one, I've got a y-intercept of 1, so I go up to a +1 and put a point. And I've got a slope of -3, so that's down 3 over 1, down 3 over 1. And of course, I'm going to graph the line. Got a little bit off there, Mr. Jansen. Okay. But we'll use our imaginations and pretend that that was spot on. And if I look at that, they intersect at this point, and the point is my answer, so I can't go anywhere without writing down the point, which looks like 1, -2. All right, so my answer for that one is 1, -2. For the next one, the problem with this next one is it's not in slope-intercept form, so I've got to change each of these to slope-intercept form. So if I take this first equation, the 2y minus x equals 4, I've got to add x to each side. So I've got 2y equals x plus 4. And then I've got to divide each side by 2. So I find out that y equals a 1/2 x plus 2. Right? Now that one's in slope-intercept form. I've got to change the other one to slope-intercept form. So for this one, I've got to subtract the 3/2 x from each side. So I find out that y equals a -3/2 x. So now I've got to graph each of these. The first one, I've got a y-intercept of 2 and a slope of 1/2, so that's up 1 over 2, up 1 over 2, or down 1 back 2, down 1 back 2. And then the next one, a slope y-intercept of 0, a slope of -3/2, so that's down 3 over 2, or up 3 back 2. And so now I'm going to graph each of these lines. And it looks like I've got something, looks like the ordered pair looks like it's around -3/4, 1 1/2, something like that. And again, I'm not sure how accurate that is, but as long as you have something close, I'd also accept like -1, 1 1/2, or maybe 2/3, 1 1/2, something like that. All right. As long as we get a general idea of where this thing is. And that's the problem with graphing. It's not always accurate. So I would accept any one of these answers. I wouldn't give you this one this hard on a test, though. So the test should be nice, neat, even points tomorrow. Okay. If I look at the next one, we want to solve by substitution. So we're solving by substitution. If I look at this first one's already solved for y. It's y equals 2 minus 3x. So I'm going to go down here to y, and I'm going to plug that in. So I've got 3x plus 2 times y, but instead of y, I'm using 3 minus 2x equals 1. So I've plugged this whole thing in for y, and now I've got to solve for x. So for this one, I've got to distribute the 2. So when I do that, I get a 3x plus 6 minus 4x equals 1. I'm going to combine like terms. The x values are alike. So that's going to give me a -x plus 6 equals 1. I subtract the 6 from each side, and I find out the -x equals a -5. And then I've got to divide each side by a -1. So I find out that x equals 5. But I'm not done yet. I still have to find y. Well, I'm going to take this first equation because it's already solved for y. So y equals 3 minus 2 times x, which x was the 5. So I've got y equals 3 minus 10. So it looks like y equals a -7. Okay? And of course, I can write this as an ordered pair, 5, -7. All right? If I take a look at the next one, again, solving by substitution, I've got to solve one of these equations for one of my variables. Okay? Doesn't matter which one. It's up to you. I'm going to go ahead. I'm going to take this first equation, and I'm going to solve it for x. So in order to solve this one for x, I've got to add the 3y to each side. So I'm going to add 3y to each side. And when I add 3y to each side, remember, I don't have like terms here, so I'm just going to write this as 9 plus 3y, or 3y plus 9. And now I'm going to plug this back in for x. See, this is my new x value right here. So I'm going to go back over to my other equation and plug that in right there for x. I'm going to plug that in for x. So let's see, that's going to be 3y plus 9 plus 2y equals a negative 1. Now I've got to solve for y. So here I can get rid of the parentheses. I can lose those. And then I'm going to combine like terms. The 3y and the 2y gives me a 5y plus 9 equals a negative 1. I subtract the 9 from each side and find out that 5y equals a negative 10. Divide each side by 5. And it turns out that y equals negative 2. But I'm not done yet. I've got to go back and plug that in. So I'm going to plug it into this equation right here. So I find out that x equals, if I plug the negative 2 in, it's going to be negative 2 plus 9. So let's see, that's going to be x equals negative 6 plus 9. So x equals 3. Again, as an ordered pair, 3, negative 2. Done and done. All right. Moving right along, if I take a look at the next one. Again, solve by substitution. If I look at this one, it's already solved for y. In fact, both of these are already solved for y. Y equals this. All right? And I'm going to go right here, and I'm going to plug that in for y. So I've got negative 3x plus 1 equals x minus 7. Okay, I plug that first value, y value, into the second equation. And I've got to solve for y. I'm going to subtract the x from each side. So I've got a negative 4x plus 1 equals a negative 7. We're going to subtract the 1 from each side, so I find out the negative 4x equals a negative 8. And now I've got to divide each side by a negative 4. So it turns out that x equals a positive 2. But I'm not done yet. I've got to plug that back in. So y equals negative 3 times 2 plus 1. So y equals a negative 6 plus 1. So it turns out that y equals a negative 5. And again, as an ordered pair, it's 2, negative 5. Yay, we did it. Next one. For this next one, again, we got to solve for one of the variables here. Doesn't matter which one. It's up to you. I'll take this second equation. I'm going to solve for x. So I've got to add the 2y to each side. So I find out the negative x equals 2y minus 3. I've got to divide each side by a negative 1. So I find out that x equals, that's going to be a negative 2y plus 3. Okay? So now I've got my x value, my new x value here. And I'm going to plug that in to the first equation where x is. So I've got 2 times, instead of x, I've got the negative 2y plus 3 plus 4y equals 6. So again, I want to distribute the 2. So that's a negative 4y plus 6 plus 4y equals 6. I combine like terms, the negative 4y and the positive 4y. I'm going to rewrite that over here. So that would give me, well, when I add those together, it's 0, so I'm just left with a 6. So I get 6 equals 6, and that's a true story. 6 does equal 6. So what I'm going to say here is this is infinite solutions. And again, it's not all real numbers, because it can't just be anything. Okay, it's still very specific ordered pairs, but there's an infinite number of them. Okay? Solve by elimination. If we look at this one, this is the poster boy for elimination right here. Okay? If we look in front of these guys right here, I see that I've got a positive y and a negative y. So I know when I add those together, they're going to cancel out. So that's what I'm going to do. I'm going to add these two equations together. So the 2x plus the 3x is a 5x. Y plus negative y is 0, so that's gone. 5 plus 20 is 25. And I've got to solve for x. I divide each side by 5. So it turns out that x equals 5. But I'm not done yet. I still have to plug this in and solve for y. So I'm going to plug this into the first one. So I'm going to have 2 times 5 plus y equals 5. So I've got 10 plus y equals 5. I've got to subtract the 10 from each side. So it turns out that y equals a negative 5. Oh, isn't that nice? 5, negative 5. It's just too easy sometimes. If I take a look at this next one, all right, with this next one, this is not quite as easy as number 7. With this one, I've got to change these numbers by multiplying by something in order to get additive inverses, okay? So if I've got like a positive 10 in one and negative 10 in the other. So you can either use the x values or the y values. I'm going to use the y values only because they're smaller numbers here, okay? So I've got a 3 and a 5, which means I can multiply the first equation by 5. And I can multiply the second equation by a negative 3. And here's why I'm doing that. If I multiply the first equation by 5, it gives me 30x plus 15y equals 30. And when I multiply the second equation by a negative 3, it gives me a negative 24x minus 15y equals a negative 36. So the reason I did that is because now if I look, I've got a positive 15 and a negative 15. Those are additive inverses. So now when I add these two equations together, they're going to cancel out. Okay? So now I can add these two equations together. And when I do that, the 30x plus the negative 24x is a positive 6x. 15y plus a negative 15y is 0. So that's gone. And then over here, 30 plus the negative 36 is a negative 6. Now I got to solve for x, divide each side by 6. I find out that x equals a negative 1. But again, I'm not done yet. I've got to take one of these equations. So I'll probably come up here and I'll take this first equation. I'm just going to plug everything into that. So let's see, that's going to be 6 times a negative 1 plus 3y equals 6. And now I've got to solve for y. So I've got a negative 6 plus 3y equals 6. I've got to add 6 to each side. So I find out that 3y equals 12. And now I divide by 3 to get y equals 4. So it looks like my ordered pair is negative 1, 4. All right? For the next one, again, solving by elimination. If I look at this next one, again, I need to get additive inverses. So I can either use the x values or the y values. I'm probably going to use the x values here just because they showed up first. I don't know. That sounds like a valid point, Mr. Jansen. Yeah, they showed up first, so let's deal with it. So I'm going to multiply this first one. That was terrible. I just crossed out half my problem, didn't I? Let me try again. That you did, Mr. Jansen. That you did. Okay, so I'm going to multiply this first equation by a negative 4. Whatever I do to one side, I have to do the other side. So let's see. That's going to give me a negative 4x plus 12y equals a negative 64. Oh, brr. And I'm going to rewrite that second equation just so you can see it a little bit better. Okay, and I did that. I used a negative 4 because now it gives me additive inverses in front of the x. So now, when I add these two equations together, the x's are going to cancel. Negative 4x plus 4x is 0. So then I do 12y plus a negative y is going to give me an 11y. And then over here, negative 64 plus 9 is going to give me a negative 55. And now I can divide each side by 11. So I find out that y equals a negative 5. But I'm not done yet. I've got to plug it back in. So I'm just going to, again, I'm going to use this first equation. Yeah, it looks like as good of any to plug into. So I'm going to have x minus 3 times a negative 5 equals 16. If I could write a 16, I would know I wouldn't have a horizontal line in there anywhere. So anyway, I'm going to multiply. So that's going to give me a plus 15 equals 16. Now I just have to subtract the 15 from each side. And it looks like x equals 1. So my ordered pair here is 1, negative 5. It's just too easy sometimes, Mr. Jansen. I know.